Today we are going to look at a past paper. This was test 1 of 2009. I posted the paper in the WhatsApp group and it's also here on Teams, so you can download it and follow along so I don't have to write down the questions. So let's get into it. So those are the kind of questions that you can expect for the test. Let's start with 1.1.1. So we are asked to prove that the hyperbolic sine of minus x is equal to minus the hyperbolic sine of x. So if you remember, this was one of the identities. This was one of the identities that we listed, and you do need to know to some extent how to prove identities that involve hyperbolic functions. And the way we do them is exactly the same as the way we did the trigonometric ones. You pick a side, you simplify it, or you work on it until what you have is what is on the other side. So here we start on the left-hand side. So we have the hyperbolic sine of minus x. And this we know by definition is e to the power of minus x minus e to the power of minus x over 2. And here negative of negative x is just x. So this is e to the power of x minus e to the power of minus x. Then here we have e to the power of x divided by 2. We can factor out negative 1 here. So this is negative e to the power of x minus e to the power of, like that, e to the power of x, okay, like that, divided by 2. Now we know that this part over here is equal to the hyperbolic sine, so this is minus the hyperbolic sine of x. So you can see that our left-hand side is equal to the right-hand side. With that one, nothing too difficult to do there. Then 1 point. Yeah, somebody's saying something, but they're very soft. Yeah.
How did you factor out negative 1?
Do you not know how to factorize?
If you factor out negative 1, is e to the power of negative x not also going to be negative e to the power of x?
Negative here.
Yes.
It is negative. Are you saying I should put a plus here, or what are you saying?
Yeah.
This should be a plus. I can't hear your answer. Are you saying this negative should be a plus?
Yes, ma'am. Shouldn't it be a plus? Because you're factoring out the negative, right?
No, it should not. Try multiplying out the brackets and see if you end up with what you started with.
I see, ma'am. You swap the two e's. Is that right, ma'am?
Did I?
Ma'am, did you swap
Did
e to the power of negative x with e to the power of positive x when you factor it out?
Okay, does that change the question?
Is that what you did, ma'am?
No, I'm asking you if there's any difference. If I write -1 plus 2 and 2 minus 1, is that a completely different thing?
No, I didn't get you there. Say again.
I have -1 plus 2 and 2 minus 1. Are these two different?
Oh no, ma'am. You see, I didn't see you doing it, ma'am, so I got confused.
Okay, the reason I wrote it like that is so because the definition of sine hyperbolic of x, it's the e to the power of x that comes first. But it doesn't make a difference even if I write negative e to the power of minus x plus e to the power of x. It's exactly the same. But yeah, that is the answer. Okay, then the next one, 1.1.2, we have to show that cos of tan inverse of x is equal to 1 over the square root of 1 plus x squared. So I think this one we did show it some time back when we were working out the derivatives of arctrig functions. Somebody saying something, hearing a lot of background noise. Okay, so again, same thing, pick a side. So let's say we have the left-hand side. So we have cos of tan inverse of x. That is what we have. Then what we can say is let y equal to tan inverse of x. And we know that if y is tan inverse of x, this means that x is equal to tan of y. Now, if x is equal to tan of y, we can represent this in a right angle triangle. So we draw our right angle triangle like that. We put our y somewhere there, and we're saying that tan of y, which is the opposite divided by the adjacent, so x is just x over 1, so we can make this one x and then this one 1, so that tan of y is opposite over adjacent, which is equal to x. And then using Pythagoras theorem, we can say that the hypotenuse is x squared plus 1, or 1 plus x squared. Yeah, 1 plus x squared is the one in the question, but again, they are the same. All right, so what we are actually trying to work out is cos of tan inverse of x, which is just cos of y, because we said y is tan inverse of x. So we go back to our triangle and work out what is cos of y. We know that cos is the adjacent divided by the hypotenuse. So here, just to note, this is the adjacent over the hypotenuse. Our adjacent is 1. Our hypotenuse is x squared plus 1. And this is the right-hand side that we were trying to show. So we can see that cos of tan inverse of x is in fact equal to 1 over the square root of x squared plus 1. Okay, so you can see not a very complicated paper, nothing to be scared of. Let's move to 1.2. With 1.2, we have to work out several derivatives. Start with 1.2.1. We are given that y is the square root of x squared minus 1 multiplied by sec inverse of x. And then we have to differentiate this. So again, standard derivative, we just have to use our product rule because this is a product. So y prime here, this is the first one as it is. So it's the square root of x squared minus 1, and then multiply by the derivative of sec squared of x, sec inverse of x rather. The derivative of sec inverse of x, if you remember from your table, is 1 over x square root of x squared minus 1. Yeah, so this is 1 over x square root of x squared minus 1. Okay, so that's the first part. Then the second part, we differentiate this one here. So the half comes down. We have x squared minus 1 to the power of minus a half. And then we multiply by the derivative of what is inside the brackets, which is 2x. And then again, we multiply by the second function exactly the way that it is. So this is sec inverse of x. So we can see some terms will cancel. This square root of x squared minus 1 and square root of x squared minus 1 there will cancel. So here I'll be left with 1 over x. Over here, only the 2's can cancel, so half times 2, those 2 can cancel. And then everything else, we will write it the way it is, cannot simplify it any further. So our y prime is 1 over x plus x times sec inverse of x over the square root of x squared minus 1. So as always, if it is possible to simplify it further, go ahead and do that. But for this one, I don't think it's possible. So we can just leave it like that. Mm, 1.2.2. We have to work out the derivative of this function. Y is equal to x times hyperbolic sine inverse of x over 3 minus the square root of 9 plus x squared. Okay, to find this derivative, for the first part, we will have to use the product rule, and then this one we just differentiate it as we always do. So y prime, this is x the way it is, and then we multiply by the derivative of sine hyperbolic of x over 2. So we know how to differentiate, excuse me, sine hyperbolic. In the numerator, we have the derivative of x over 2, which is 1 over 3. And then in the denominator, we have the square root of our function squared. So I have x squared over 9 and plus 1. Okay, that is the derivative of hyperbolic sine from our table. And then the second part, we're still differentiating. This one is the derivative of x, which is 1 multiplied by sine hyperbolic inverse of x over 2. So we have the sine hyperbolic inverse of x over 3. And then we differentiate this function. So this is minus, the half comes down, 9 plus x squared to the power of minus a half. Then we multiply by the derivative of the inside, which is 2x. Now, if there are any terms I can cancel, we go ahead and do that. So you can see the 2's will cancel. And this one here, we can simplify it because the 1/3 can come out and then cancel with that one. Yeah. Okay, so y prime, this is x/3, and then in the denominator I have x² plus 9/9 plus hyperbolic sine inverse of x/3 minus x over the square root of x² plus 9. Okay, then here this 9 can come out of the square root, so it's 1/3. So I have y prime, this is x/3, and then in the denominator I have 1/3 square root of x² plus 9 plus hyperbolic sine inverse x/3 minus x over the square root of x² plus 9. So you can see this is x/3 divided by 1/3, that is just equal to x. So I have y prime is x over square root of x² plus 9 plus hyperbolic sine inverse x/3 minus x over the square root of x² plus 9. And this first term and the third term are the same except for the sign, so they can cancel each other out. And then I'm left with y prime is hyperbolic sine inverse of x/3. So y prime, this is hyperbolic sine inverse of x/3. Then 1.2.3, we are given x is equal to 1/e⁻⁷ and y is equal to e⁻²t, and we still have to work out the first derivative, that is dy dx. So here you need to remember this is we will use parametric differentiation, and in doing that keep in mind that dy dx, this is dy dt divided by dx dt. Okay, so we just need to differentiate y with respect to t, differentiate x with respect to t, and then divide the two. So dy dt, this is 2e⁻²t, and then divide by the derivative of this with respect to t. So remember 1/e⁻t is e⁻⁻t. So when you differentiate that, that is minus e⁻⁻t. And here, this is -2e⁻3t. So the bases over here are the same. We are dividing, so we subtract the exponents. 2t minus -t is 3t. 1.3. So with 1.3, we have y is equal to arc cos of that, which is just cos inverse of 2 plus 3 cos x over 3 plus 2 cos x. We're told that x is between 0 and pi, and we have to show that the derivative is square root of 5 over 3 plus 2 cos x. So I usually like these questions because you know what the answer, you know what the answer is, so you're sure whether you're right or wrong. Okay, so differentiating this, we will have to use the derivative of cos inverse. So remember, y prime. This is the derivative of cos inverse. In the numerator, we put the derivative of this function here. So it's negative. So first of all, I'll just write it the way it is. Okay, and then the prime there that says I must still differentiate it. And then in the numerator, we have the square root of 1 minus the same function squared. So this is 2 plus 3 cos x over 3 plus 2 cos x squared. So that is going to be our derivative. So you can see it isn't a difficult function to differentiate, just will involve a lot of terms. And when there's a lot of terms, it's quite easy to make a mistake. So be careful when you are differentiating this. Okay, let's go ahead and differentiate it. Say that our y prime. Now we differentiate the numerator. So that is 2 plus 3 cos x over 3 plus 2 cos x. We use the quotient rule. In the numerator, we have the denominator as it is. So it's 3 plus 2 cos x. And then we multiply by the derivative of the denominator, which is negative 3 sine x. And then we subtract. Okay, here there's this negative that I should put there. So this negative is this negative here. So don't forget about that one. And then minus the derivative of the denominator, which is negative 2 sine x. And then you multiply by the numerator as it is. The numerator is 2 plus 3 cos x. And then divide by the denominator squared, which is 3 plus 2 cos x, all things squared. So that is our numerator. And then in the denominator, we have this big square root. So we have big square root, and this square root I can simplify it or rewrite it as 3 plus 2 cos x squared minus 2 plus 3 cos x squared over 3 plus 2 cos x squared. Okay, right, now let's simplify the bracket over here as far as possible. Okay, so here you can see I have negative and negative. That will obviously become a plus, and then these ones we can just multiply. So I still have my negative outside. Then I have 3 times negative 3 sine x, which is negative 9 sine x. And I have 2 cos x times negative 3 sine x, which is negative 6 sine x cos x. And then we say negative and negative makes a positive. So I have 2 sine x times 2, which is 4 sine x. And then I have 2 sine x times 3 cos x, which is positive 6 sine x cos x. Okay, and this is still divided by this term here, 3 plus 2 cos x squared. And I close my square brackets. So that is the numerator in the numerator. Then I look at this one over here. You can multiply out the brackets, or you can use the difference of squares to simplify it, whichever one is easier for you. So in the denominator, I have the square root of, let's say we have 3 plus 2 is 5. And then I have 2 cos x plus 3 cos x. So in the first bracket, I will have 5 plus 5 cos x. Okay, so I'm factorizing this using the difference of squares. So it's the first bracket plus the second bracket multiplied by the first bracket minus the second bracket. Then in the second bracket, I have 3 minus 2, which is 1, and then 2 cos x minus 3 cos x, which is minus cos x. And then this is divided by, so you can see the square root is square root of the numerator over the square root of the denominator, and the square root of the denominator just cancels the square. So I have 3 plus 2 cos x. Okay, so here in the numerator, you can see that the minus 6 sine x cos x and 6 sine x cos x can cancel. So I will be left with negative 5 sine x. And then here, I see 5 is a common factor, so I can take it out. And I could also multiply the negative in, but let's see what we have. So let me leave the negative out first. So we say negative 9 sine x plus 4 sine x is negative 5 sine x. And then the denominator of the numerator, we have this 3 plus 2 cos x squared. 3 plus 2 cos x, the whole thing squared. And this is being divided by this one over here. So we said we can factor out the 5, the square root of 5. 1 plus cos x, 1 minus cos x, and then in the denominator we have 3 plus 2. Yeah?
I'm lost.
Somebody's saying something? I can't hear you.
Miss, I'm lost.
Why are you lost?
Which function are you factoring out there?
Here.
Everything on that screen.
What do you mean everything that's there?
Like it is the previous one of the denominator or the numerator.
When you say the previous one of the denominator, or I'm not sure what you mean, but this one here in this.
Which one, man?
This one here in the square brackets is this one here. I've just simplified it. And then this one is the one that was at the bottom. Okay. Then we have negative and negative. That gives us positive. So we have 5 sine x over 3 plus 2 cos x squared. And we know that when we are dividing fractions, the division changes to multiplication, and then we write the reciprocal of this one here. So the reciprocal is 3 plus 2 cos x over the square root of 5. And here, 1 plus cos x multiplied by 1 minus cos x. This is 1 minus cos squared of x. And we know that 1 minus cos squared of x is sine squared of x. So this is 5 sine x over, you can see here, these two are the same, except this one is a square. So the square will cancel with that one. And then over here, I am left with 3 plus 2 cos x times 1 over the square root of 5 sine squared of x. Okay, and we can separate the square roots over here and say this is the square root of 5 times the square root of sine squared of x, which is just sine x. So I have 5 sine x over 3 plus 2 cos x times 1 over the square root of 5 times sine x. And you can see the sine x's will cancel. And then I have 5 divided by the square root of 5, which is square root of 5 in the numerator, and 3 plus 2 cos x. And this is what I was asked to show. Okay, so again, not particularly a difficult question. It's just the algebra of it, which you need to do carefully and make sure you don't make mistakes. But like I said, I like questions like this because you know if you are right or wrong, because you know what the answer is supposed to be. Okay, so that's that one. Then 1.4, again, we have y is equal to 1 plus the hyperbolic tan of x over 1 minus hyperbolic tan of x, and then we have to show that the derivative is equal to 2e to the power of 2x. So this is 1.4. We have y is equal to 1 plus hyperbolic tan of x over 1 minus hyperbolic tan of x. Then we have to find the first derivative. So to find the first derivative, all we do is use the quotient rule. So we know that y prime is the denominator as it is, multiplied by the derivative of the numerator, which is just sec hyperbolic squared of x. And then we minus the derivative of the denominator, which is minus sec hyperbolic squared of x, multiplied by the numerator the way it is, and then divide by the denominator squared. Okay, so again here we can see negative and negative will make a positive. So the first term has sec hyperbolic squared, the second one is sec hyperbolic squared, so we can factor that out. So this is sec hyperbolic squared, and we have 1 minus tan hyperbolic of x. And remember, negative and negative here is positive, so I'm left with positive 1 plus tan hyperbolic of x. So plus 1 plus tan hyperbolic of x. So I just factored out the brackets. This is the first bracket, multiplying by that. This is the second bracket, multiplying by that one. Then we divide by 1 minus, like that, squared. You can see the tans there cancel. In the numerator, I'm left with 2 sec hyperbolic squared of x over 1 minus tan hyperbolic of that squared. And here the question said our answer must be in terms of e to the power of something. So we need to rewrite all of these in terms of e to the power of something. So doing that, this is 2 sec hyperbolic squared. Remember, sec is the reciprocal of cos. So this is 2 over e to the power of x plus e to the power of minus x squared. So that is the 2 sec hyperbolic squared of x. So the squared is still outside. I haven't multiplied it out. And then I'll write it as divided by this one here. So I'm splitting the fraction and using the division symbol. So this is 1 divided by, and then tan, I write it in terms of e to the power of x and e to the power of minus x. This is e to the power of x minus e to the power of minus x over e to the power of x plus e to the power of minus x. That is what tan is, and this must be squared. Okay, so here we, why did I say divide? Here we can combine these two before we square them. This one we will just have to square it the way that it is. So when we square this one here in the numerator, we have 4, so we'll have 4 times 2, and then in the denominator, I'm not gonna expand it, I'll just write it as e to the x plus e to the minus x, the whole thing squared, and then these two fractions, I combine them. What I have is 8 over e to the x, e to the minus x squared, and then dividing by this. So we said this one, I can write it as e to the x plus e to the minus x divided by that. So I have ex, e minus x minus plus e everything over like that. Okay, then it still has to be squared. So here you can see that the e to the x will cancel. So this one and that one will cancel. So I'm left with 8 over e to the x, e to the minus x squared. The division can change to multiplication, and I have e to the x plus e to the minus x squared divided by, what I'm left with in the numerator is 2 e to the minus x, the whole thing squared.
Me?
Yeah.
How did you get the 8?
The 8 I said is This is 2 squared, which is 4, and then 4 times 2 is 8.
Yes.
Okay, and then, yeah,
At at the top of your page,
yeah.
the second one, yeah, there where your cursor is. Isn't it supposed to be e to the power of x minus e to the power of negative x?
No.
Quickly go back to the previous page. You see? Can you see, ma'am?
What am I supposed to see?
E to the power of x minus e to the power of negative x.
So this one here, is it positive or negative?
It's positive. It's negative.
Okay, so you're saying I have something like this, and there's nothing here. What's this? What's the operation here?
It's a negative.
Okay, so this negative here does not belong to the e to the power of x. It's here. So I must subtract e to the power of x, and then I must also subtract negative e to the power of x. Okay, but again, this is algebra. These are not the things that you should be having a hard time with, because it's like this. This is what I have, if that helps. But anyway, okay, this is what we have. And then you can see that this one here in the denominator and that one there are the same, so they can cancel out. And then I have 8 over here, 2 e to the power of minus x squared, that is 4 e to the power of minus 2x, which is equal to 2 over e to the power of minus 2x, and this is 2 e to the power of 2x, which I believe is the answer that we were told to give. Okay, so again, with the algebra, you need to be careful when you're doing it. So make sure you don't get it wrong because of basic algebra. And that was that one. And then question 2 says use the rules of differentiation to answer each of the following questions. We have 2.1, where a boat leaves a dock at 2 p.m. and travels due south at a speed of 20 kilometers per hour. Another boat heading due east, heading due east at 15 kilometers, reaches the same dock at 3 p.m. At what time were the two boats closest together, and then prove that the two boats were closest to each other at this time. So here, closest, that means minimum, and we know when we're talking about minimums, we have to use first derivative equal to 0, and then the part that says prove that they were closest at that time, that means you check using the second derivative. Okay, so this is 2.1. So it's always helpful to draw a sketch. We have a dock over here. Let's say this is our dock, and we are told one boat is moving like that, the other one is moving in that direction because it's heading towards the dock. Now we have 2 times. We have at 2 o'clock. Obviously the second boat is somewhere here, and then we have the first boat is at the dock, so it's over here. And we are told that the second boat reaches the dock at 3 p.m. That's an hour later, and it's moving at 15 kilometers per hour. So that means this distance over here is just 15. So if it's 2 o'clock, 3 o'clock, it gets to the dock. That means it's taken an hour to reach the dock, and it's traveling 15 kilometers per hour. That means at 2 o'clock it was 15 kilometers away. Then we have their positions at time t. So at time t, we know that boat 1 is going that way, boat 2 is going that way. So here what we have is a right angle triangle like this. So the distance over here is just 15 minus 15t. So this 15 here is the 15 kilometers away from the dock that it was. And this 15t is the distance that it travels in t hours. Okay, so if you want to work out how far it's traveled in 10 minutes, you convert the 10 minutes to hours, and then you just say 50. If you want to work out how far away it is from the dock, you say 15, which is the initial distance that it was away from the dock, minus how far it has traveled in that 10 minutes. So you convert your 10 minutes to hours, and then you say 15 kilometers per hour times 10 minutes and hours. That will give you how far away it is from the dock. And then this second boat, the first boat rather, the one that's mentioned first, which is going due south, its distance is just 20t, because we know that speed is distance times time. So again, if you want to work out how far it has moved in 10 minutes, you just say 20 kilometers per hour multiplied by 10 over 60, and then that will give you how far away it is. Now what we're interested in is this distance between them. So this is our boat 2, and this is the position of boat 1. We're interested in this distance over here, which is the distance between them. And we can come up with an equation that connects all these. That's Pythagoras theorem. We know that d squared is equal to 15 minus 15t squared plus 20t squared. So here d is the distance between the 2 boats. Okay, and we can always make d the subject of the formula because we have to differentiate equate to 0, but with the first derivative we can use implicit differentiation to work out the first derivative, but use whichever one is easier for you. So we have differentiate. We have 2d times d prime. This is 2 times 15 minus 15t, and then we multiply by the derivative of the bracket, which is minus 15t, and then the derivative of this one is 2 times 20t, and then times the derivative of 20t, which is 20. So we can also divide by 2 throughout. So I have d times d prime. This is 15 minus 15t. times minus 15t plus 40, not 40, 400t, like that. Okay, and we want d prime equal to 0, so at the minimum distance, say that d prime is equal to 0. So I can make d prime the subject, just divide by d on both sides. Okay, so I just divide by d on both sides. And the first derivative is 0, so I have 15 minus 15 minus 15t minus 15t plus 400t over d is equal to 0. So multiply by d on both sides, and then we can multiply out what we have in the numerator, where 15 times minus 15t, which is negative 225. Then negative times negative, this is 225t squared plus 400t, this is equal to 0. So we have 225t squared, and then 400 minus 225, 175. Okay, then we can factorize. Where t is equal to 175 divided by 225, which is 7/9. Is that right? No, that doesn't look right. Let me just see what I did here. 2d, that's 215 minus t. Okay, I see the problem here. The derivative here should not include a t, sorry. So there should not be a t there. There should not be a t there. And there should not be a t there. There should not be a t there. So this is just 225. And this should not be squared. Okay, I think now it will be fine. Okay, so we have 225 plus 400, which is 625. T minus 225 is equal to 0. And this means that t is 225 over 625, which is 9/25. Okay, so after 9/25 hours, then the boats will be the closest they have been to each other. So this is in hours, and the question says at what time. So we need to convert that to hours and then add it to 2 o'clock, because we're starting our time from 2 o'clock. So 9/25 hours. We know that this is 9/25 times 60 minutes, which is 21.6 minutes, and 21.6 minutes is 21 minutes plus 0.6 times 60 seconds. So this is 21, let's see, 0.6 times 60, that's 36, so it's 21 minutes and 36 seconds. So we started counting our time from 2 o'clock. So 2 o'clock, you add 21 minutes and 36 seconds. So we can say that the boats will be closest at 2:21, 36, 2 hours, 21, it's 36. How do you write it? With points? Like that. Minutes, seconds, I can't remember. Anyway, at that time, that is when the boats will be closest to each other. Okay, so with the checking, you can do that. To do that, you work out the second derivative, and then you substitute 9/25 into the second derivative, show that it is equal, it is less, it's a minimum, so it must be greater than 0. So this is what you need to show, that it is greater than 0, and then that will confirm the last part of the question. And I think 2.2.3 will also not take you, 2.2 rather will not take you very long to do. So you can see in an hour, we're almost done with the paper. And this is a test that is maybe like 90 minutes. So you have plenty of time for the test if you studied. Excuse me.
But the previous studied.
Okay, so we'll stop here for today. You go and finish the rest of the questions, which are not that difficult to do. Yeah.